just to bring up another question about it. When we're talking about the energy required to get rid of the salts, if we were to eliminate, I live on a well. Okay, I'm out in the sticks in Wisconsin, and water softening is a requirement in my area. We had a failure on our water softener and really didn't realize it until our toilet turned red. And my wife was complaining about how long it took her to rinse out her hair. Now, let's go down that direction. If we have these failures like you were demonstrating with shower heads, how much energy are we losing by throwing out shower heads? How much energy are we losing by having equipment that is not operating correctly? How much more water are we using to rinse our hair, because we know that softened water cleans the hair more rapidly. At least that's what my daughters tell me.
It does.
So, I don't have that problem. But the thing about it is that I think if we started questioning beyond that, we'd find a whole list of reasons why, even though we may be introducing a smaller additive percentage of salts into the system, the opposite is just horrendous. I don't think we want to go there.
Yeah, you use less soap with softeners too, so that's less soap in the sewers as well. There's no doubt that water softeners, the salt is an Achilles heel of water softening. I wish there was a way we could get by without having salt in a water softener, and we do have softeners now that use a lot less salt. I mean, if you go, we definitely encourage people to use what we call the meter or the demand-initiated control type water softeners. They save at least 50% of the salt over what a time clock softener saves. And then we encourage people all over, not just California. It's required in California to have an efficiency rating of 4,000 grains of hardness removed per pound of salt that's used. The NSF standard only requires 3,350. But we, as an industry, encourage people to try to go to that 4,000 grains per pound. That makes a more delicate softener operation, but it saves salt. So we try to reduce the salt as much as we can, but we have not found a way to get the benefits of soft water without the salt. And the ion exchange water softener is a more robust technology and it's the backbone of our industry, because, as Tom says, a lot of people have hard water and they just cannot live with it that way. So we can't just take water softeners away, and so about the best we can do now is to get that salt down as low as we can.
One more in the back.
Hi. My name is Tom Zitch. I'm from New Jersey. I live in an area where the water hardness is about 35. Been fighting the problem for many years. The question I specifically have is, I've dealt with many water softeners. Certainly they're required and they do a great job. Along my path, I decided to go along with a water treatment system, which is not water softening. It doesn't take the salts out. It just basically is designed to, I guess, change the molecular structure of the salt so that they're larger, kind of from an LDL to an HDL type of situation where they're not sticking to the pipes. You see these things advertised on TV and Home Depot. The question is, have you done any testing on that type of stuff to see how it affects it? And what's your opinion on it? Just before you answer, I would just like to say that when I hooked up one of these electromagnetic systems to my house, of course you still get the taste in the water, so it doesn't help your cup of coffee, but I found out that it improved the lifetime of all of my faucets, my toilets, all the problem for the last 10 years, just as good as the water softener did without any of the additives. So now I use both, but I just wondered if you had any testing or information on those. So not water softening, but water treatment.
Yeah, we particularly call those not water softeners, because we want a water softener to be defined as something that makes soft water. And everybody defines soft water as water with the absence of calcium magnesium in it. You go to AWWA or whoever, and they say soft water is water without calcium magnesium in it. So something that leaves the calcium magnesium in but makes it behave different is a water conditioner or a water treatment, or we call it a physical water treatment device. And we've been pleading for years to have a standard for those, because our other technologies like ion exchange water softening or activated carbon filters or reverse osmosis systems, we work hard. I'm on the joint committee of NSF, work hard to get credible industry standards that we can test and certify these units to them so consumers can trust then that that unit will do what the manufacturer says. We don't have that for these physical water treatment devices, but I want to put a plug in here for IAPMO on this, because IAPMO has a standing committee, which we again are participating in strongly, myself and Tom Palkin and Dr. Reagan-Nathan and even Rob Herman from NSF and many people from the physical water treatment community have been working for 2 or 3 years to get a standard for physical water treatment devices that can be accredited by the American National Standards Institute, that all of our certification programs, NSF and IAPMO and UL and our WQA Gold Seal program, can then can test these units and to see that they will perform. But you've got to be careful, because I think that physical water treatment devices to an extent have some validity. I think there are some of them, and maybe many of them, that do in fact have the ability to take that dissolved calcium magnesium and form it into what we call nanocrystals of precipitating scale that are floating in the water. And as long as you can maintain those nanocrystals of scale precipitated out, then they won't scale out on your heating element or your pipe walls. But those nanocrystals of precipitated scale are not permanent. They're not completely stable. They can revert back to dissolved scale. And we've found like the Germans have a standard, a GVGW standard, and it's a water heater standard, but it only allows you to have a water heater up to 6.5 watts per square centimeter of energy in the heating element. And you can run the test anything you want below that. So the people that have passed that standard, they run the water heater at 3 or 4 watts per square centimeter of heat intensity in the heating element, and they work fine. But then when we've taken these same units and run them through a water heater at what that German standard allows of 6.5, they don't work as well. And then when we go and buy a water heater in the United States, like these water heaters at Battelle, where I think about 15 or 18 watts per square centimeter, I think most American water heaters are at least 10 or 12 watts per square centimeter, you try to run these same devices, the same precipitated nanocrystals of scale, through that kind of a heat intensity in the element, and it's just like they weren't there at all. So I can't say that these things don't work. One time we did say that magnetic water treatment doesn't work. We can't say that. I think there are some of these pulse water treatment and the template-assisted crystallization medias that do have an effect sometimes on some waters, and I get reports just like what you say, that I truly believe from credible people that it makes my fixtures better and it makes things work better without the salt. And I think that there are cases where it will work. But there are other cases where the intensity to form scale, either the pH is so high or the concentration is so high or the heat intensity is so high that it just overwhelms the ability of these crystals to stay permanent, and they revert back just like they were never there at all. So they don't work all the time, and they don't work as completely as a water softener. And so I just don't have the confidence right now to tell you that this device will work, or particularly that it will work in all applications. And we're trying to get this standard written, and IAPMO has made very good progress on it. Because the no salt water softeners have gotten such a boost lately, now it seems like everybody, NSF came to us and said, well, let us write this standard. Well, IAPMO's got the ANSI PIN number for it, and IAPMO's going to run this standard, so we're all going to participate and try to get it done through IAPMO, and hopefully we'll get that standard done, and we'll be able to answer those questions then with testing and certification as to whether these things really do work, and we can trust them.
So stay tuned for the developments. Thanks, Joe.